Let's go ahead and get started with 4.5. We're going to do triangle congruence. Okay, triangle congruence, and there is SSS and SAS. Okay, just for information, the S's and the A's. So S stands for side. Okay, so S here means a side, A means angle. Okay, so this would be side, side, side. Side, angle, side, okay? Side, angle, side, all right? Okay, so we're gonna go ahead and find, there are many different ways a triangle can be proved to be, two triangles can be proved to be congruent, okay? Meaning the same, right? There are many different ways. And in 4.5, we're gonna talk about the first two, which is side, 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 angle, side. Okay, so let's go ahead and look at that. If you go to page 250, there is a postulate there in the middle of the book. Says that side, side, side congruence. If three sides of one triangle are congruent to three sides of another triangle, the triangles are congruent. Okay, if you see there is a triangle ABC and triangle FDE, okay? So if I said, so the book says triangle ABC is congruent to triangle FDE, okay? Can I write this as DEF? So it's like in order, DEF, ABC, DEF. Can I do that?
No.
Huh? I heard a no. Somebody said no. Why not? By the way, no is the correct answer.
The sides have to correlate to one another.
Correct. They have to correspond with one each other, right? If you look at that, side AB is 4 centimeters there, right? If I wrote it this way, that means that AB would have to correspond to DE. If you look at DE, DE is 6 centimeters. So obviously they do not correspond with each other, right? So again, like we said last week, they have to correspond with each other, okay? So to make that happen, it has to be written FDE. And basically there really is only one way to write this. Okay? Unless you want to rewrite this as triangle BAC, which you could write this as BAC, all right? Then you'd have to correspond this, look at the spots, all right? So B would be D, A would be F, and then C would still be E. So it would be a different statement then, right? Okay, because you could call the triangle not ABC, but BAC, right? Because there really is no convention there, right? Okay, as long as the corresponding parts are correct, it works, all right? Okay, so again, we kind of revisited the how to write the statement, right? Okay, so let's take example number 1, use side, side, side to explain why triangle PQR is congruent to triangle PSR. Okay. All right, so we have what? So we have PQRS, and we are told that these two are the same and these two are the same. All right. So if you look at the triangle P, okay, so they share PQR has this leg or this side, and this side, right? If you look at P, and then if you look at PSR, this side and this side are congruent to this side and this side, and it actually shares a side. So obviously PR is going to be congruent to itself, right? So you have side, side, side on the triangles, okay? And that's how it works. Okay, the second one is postulate 4.5-2 or 4-5-2, whatever, okay, on top of page 251, it says side, angle, side. So this is the second one. The first one was side, side, side. The second one is a side, angle. So one side, angle, and a different side, right? So if those two are congruent on both triangles, right, there's only one other way that you can connect the other two. I mean, you can complete the triangle, right? So basically, that's why these two triangles would be congruent if the sides are congruent, the angles are congruent, and the other side is congruent, right? So side, angle, side. So remember that when it says side, angle, side, this is different than side, side, angle, right? Side, side, angle means you have two sides, one side, two side, and you have an angle over here. Okay, you would have an angle over here, all right? Because it's side, side, angle, side, side, angle, all right? So this guy here is side, angle, side, so not to be confused with this. This is side, angle, side, all right? Side, angle, side, all right? So that's the second way to be congruent. So let's go ahead and read that postulate. It says at the top of page 251, if two sides and the included angle of one triangle are congruent to two sides and the included angle of the other triangle, then the triangles are congruent, right? The two sides and the angle between it, two sides and the angle between it, okay? All right. Okay, so let's see if we can use this to do example number 2. Example number 2. We're going to have the figure shows a part of the support structure of the Statue of Liberty. Use SAS to explain why triangle KPN is congruent to triangle LPM. Let's go ahead and see if we can draw this out. We're going to have, looks like something like this. We have KPNML, and we are given that these two are congruent and these two are congruent, okay? So it tells us to use SAS, okay? We need these two sides are the same, these two sides are the same, right? So we need to prove that this angle is congruent to this angle. So if angle MPL and angle NPK were congruent, then we would have a side angle side situation, right? Because we would have the two sides and the angle between, two sides and the angle between. How would I prove that these two angles are congruent? Anybody? Or the correct answer, correct question would be, why are they congruent? What are these two angles called? There's a special word for this.
Vertical angles?
Huh?
Vertical angles?
They are vertical angles, correct. They are vertical angles, right? Because two lines here, and you have these two angles are the same, these two angles are the same, correct? So you have vertical angles. They are vertical angles, therefore these two angles are congruent. The two sides are congruent, therefore from SAS, side, angle, side, the two triangles are congruent. Okay, good. All right, let's go to example number 3. Example number 3, we have show that the triangles are congruent, and we are given UVW, and we are given something like this. And we have 2, 3, 4. And we have x, 3x minus 5. We have x minus 1, z, y, x. Okay, and we are told that x is equal to 3. Since x is equal to 3, I can go and actually find out what this is. So this is 3, right? 3 minus 1 is going to be equal to 2. Over here, I'm going to have 3 times 3 minus 5. So I'm going to have 9 minus 5. It's going to be 4. So I have 3 sides, 2, 3, 4. 3 sides, 2, 3, 4. Therefore, these two triangles are congruent. Okay, so if I had to write these statements, I would write triangle VU W is going to be congruent to triangle. What's the corresponding part to VW here? VW would be here, right? So it would be XZ, and UW is 2, which is going to be here, so it would be ZY, right? So this would be my statement, right? Triangle VUW is congruent to triangle XZY. Okay. Or the book says UVWYXZ. Okay, same thing. Okay, so that's the first one. Let's move on to the second one. We have DEF, and we have GJH, 15, 24, 126 degrees. And we have 2y plus 1. We have y squared minus 4y plus 3. We have an angle measure of 12y plus 42. And we are given that y is equal to 7. Since y is equal to 7, I can go and calculate all the other stuff out here. So y is equal to 7. 7 squared minus 4 times 7 plus 3. 49 minus 28 plus 3. Right? 49 minus 28 is 21. Plus 3 is 24. This guy here is going to be 2 times 7 plus 1. That's a 1. So I'm going to get 14 plus 1 is equal to 15. This guy here is going to be times plus 42. That's going to be 84 plus 42, 126. Okay. 15, 24, angle in between is 126. 15, 24, angle between is 126. So because of side angle side, from the side angle sine congruence theorem, it's going to work, right? So let's go ahead and write the DEF. DEF would be what? DEF would be JGH, right? Triangle JGH. Okay. All right, so that's that. Example number 4. Let's do the last one, example number 4 here. example number 4. Given that L and M are parallel and EG and HF are congruent, prove that, okay, so let's go ahead. L, M are parallel, so these two are parallel. And then we have E, G, F, H. Okay, we are told that EG and HF are the same, so this guy and this guy are the same. Okay. So, and we're trying to prove that triangle EGF is congruent to triangle HFG. Okay, so let's see if we do this. So what do we know here? We know that since these two are parallel, I know that this angle and this angle are the same. They're congruent, right? And they're going to share this guy here. So I have side, angle, side, side, angle, side. Okay, so see how that works? So I have side, angle, side, side, angle, side, right? Okay, so I have no proof. I don't know. I know that these two are the same. I know that these two are the same, but there's no way for me to know that this guy and this guy are the same. Okay, so that would be SSS, side, 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 but there's no way for me to prove that this guy and this guy are congruent. So I have to use the angle. So I'm looking at the angle. I know that this guy and this guy are the same. This guy, they share. So I'm going to try to see that these two angles are the same. And the way their two angles are the same is because they are interior alternate angles, correct? They're interior alternate angles. If you look at a transversal this way with the two parallel lines this way, right? Okay. So the proof, if you go through the statements, let's go through the two column statements there. It says that EG and HF are given. L and M are parallel, that's given. And then EGF and HFG are alternate interior angles, and we just talked about that. And then PFG and GF are the same. In other words, this guy here is shared in both triangles, and therefore they are congruent due to side angle side. Okay? All right, any questions there? Are we good? Do you feel a little lost, or hopefully this makes a little more sense? And then I'll go ahead and give you your homework here. (8 through 20, 28 through 31).